A very good afternoon to you all, and a warm welcome to our webinar on Build for 100 Years, a performance concrete, a high performance concrete, chemicals and materials. Today's webinar is a collaborative initiative organized by the Structural Design Institute in partnership with the Open University of Sri Lanka, Resource Centre and Fostro. We are delighted to have you with us for what promises to be an innovative and engaging technical session. For those joining us for the first time, SDI or Structural Design Institute, more commonly known as SDI, is an educational institution dedicated to advancing engineering knowledge through professional development, technical webinars, and specialized training in structural engineering, construction, and engineering software. So what sets us apart is our close affiliation with civil and structural engineering consultants, one of Sri Lanka's leading engineering consultancy companies with decades of experience delivering some of the nation's most iconic and complex engineering projects. At SDI, we are committed to the continuous professional development of engineers by offering CPD courses, technical webinars, and industry-focused events for professional undergraduates and those pursuing chartered engineer status. Our program covers a wide range of disciplines, including structural analysis and design, construction engineering, project management, and emerging technologies in the built environment as shown on the screen. A key strength of our institute is our faculty, comprising of experienced industry practitioners and international recognized academics who bring real-world expertise directly into every season. So you can see some of our webinars and technical sessions, courses, and workshops that we have conducted and we are conducting so on the screen. In addition to our educational programs, SDI has also published several technical references, including the Tall Building Guidelines for Sri Lanka, Construction Specification for Tall Buildings Sri Lanka, the Lotus Tower publication, and the Structural Detailing Manual, as shown on the screen, and with more to come. These publications reflect years of practical experience and research, providing valuable guidance to engineers involved in the design and construction of modern infrastructure. So before we begin today's webinar, I'd like to briefly go through a few housekeeping points to help ensure a smooth session for everyone. Firstly, if you have any questions during the presentations, please post them in the YouTube live chat, and we will collect your questions and direct them to our speakers during the Q&A session at the end. Secondly, a certificate of participation will be awarded to everyone who completes the attendance form, which we have given in the YouTube live description. This is not open yet. We will also share this live link on the live chat of the YouTube. So you can go through the Google form and fill in your attendance. But please note that the attendance form is not open yet, and it will only be available once we announce it during the webinar, and we will announce this in the YouTube live chat. So please keep an eye on the live chat for the notification. Today's webinar brings together experts from academia and industry to discuss one of the most important challenges facing the construction sector today: building structures that are durable, sustainable, and capable of serving future generations. Throughout this session, we will explore how high-performance concrete, advanced construction chemicals, and innovative materials are transforming the way we design and construct long-lasting infrastructure. The discussion will cover modern material technologies, durability enhancement strategies, sustainability, and practical applications that contribute to extending the service life of structures. So we are honored to have us with three distinguished speakers who bring a wealth of knowledge and experience from research, academia, and industry. Let me introduce our first technical presentation resource person, Dr. Tushara Priyadarshan. Dr. Tushara is a senior lecturer at the Open University of Sri Lanka and currently serves as the chairman of the Small Holding Development Authority. With over 21 years of professional experience, He has held senior positions in both academia and industry, including the Housing, Elford Housing, and Inci Cement. And where he has specialized in concrete innovation, research and development and technical services. He holds a BSc in engineering from the University of Peradeniya and MSc in project management from the National University of Singapore and PhD in engineering from the University of Peradeniya. He is also an active member of professional bodies, including the American Concrete Institute and the Council on Tall Buildings and Urban Habitat. Please join in me welcoming Dr. Tushar Priyadarshan. Over to you, sir.
Good afternoon, everyone. Thank you very much for Mr. Fernando and all the team. So it's known to us quite a long time. And Professor P.R. Mendit, I hope he will join during the session. And Mr. Paran from India, from Postdoc, he also will present with him. So thank you very much for inviting me. So if you go to the presentation, so first of all, I think one connection I'm the requirement at the moment in ESDA, but I noticed. So if you go to the next slide. So actually, this is where I have studied already CS medicine. So this is where I have worked. So I have been in the industry, corporate sector, African engineering contractor, engineer in consultant, and different phases. So then I joined Holcim. I worked there for almost 10 years. Holcim, then it became Apache Holcim, then Inci. Then later, after my PhD, I thought to join Open University, which I can work until 65. So then this is my corporate where I have worked. So I have been the chairman, I can see told me. I have been there for 2 years. And at that time, I was the director for T-Board, National Institute of Plantation. Then Turusavia, I was chairman for a very short period of time, of 3 months, just to close. So then the director for T-Board, I was coordinating secretary for State Minister for almost 1 year. So, and I was the director for relationship, international relations in Open University. So, and I have 2 companies, but very small. So, out of this, actually, what I actually just I have been in many industry and had. So I hope today I will share my experience with you, especially related to concrete, which I have been practicing in last almost 20+ years. So just to get an introduction, so build for 100 years is not a magical thing. So because you all guys design for 100 years and at least 50 years. The issue is that, so even though you design it for 100 years, most of the structures doesn't last for 100. That's the issue. And beyond 100 years also, sometimes you have to design like iconic structures. So of course, it should be more than 100 years to be. So if it is the reality, can we do it? You ask question from yourself or ourselves. So we can do it very easily because there are enough structures in the world which have been lost. This is. So probably. Okay. So this is okay. You can read the text. Don't worry. But this lasts for last 5,000 years. But probably you can say that this is not concrete, but this is concrete like material. So of course, they have been used for limestone and gypsum for this particular. Actually, they have calcined the limestone and used it for this. So this lasts for 5,000 years. And this lasts for 2,000 years. They have used fly ash and gypsum. Of course, gypsum they have used and fly ash and some other materials. So mainly fly ash. So this is 2,000 years. So do you have structures in Sri Lanka last for so many years? Yeah, a lot. Have a lot of stuff. This is 1,700 and this is brick. But of course, they have used mortar with some of the ashes that they found. So if you should think back why they last quite a long time is, one reason is actually okay, this one more thing. This is Mavanala Bridge. This is brick. Even today it operates as normal in Mavanala part of it.
Okay, folks, we have arrived at a very special place. I wonder if you can remember, because I was telling you that we'll be visiting a very historical brick bridge.
Sri Lanka, you can name it probably more than me. Most of the like 9.5 bridges.
As you can see, there's a plenty of history behind it, because the British who commissioned
along the railway line. Lot of bridges are there. It has been done with bricks. Of course, one thing you can notice is that for most of the structures, they have followed arch behavior just to avoid the tension on the structure. So if you go back to all the structures, except the pyramid, because you can design it in different ways. All others, they have those arches. Because all this material has enough compressive strength, but on the other hand, you know that the tensile strength is very good. So even though structural engineers like to use a lot of reinforcement in structure, so this is the major issue in the recent past in the modern concrete, that when we introduce reinforcement into your structure, then it is the issue for the durability, main issue. So that's why I see some of the structures like Acropole. This is Colombo Harbour, but that photo is not the same Acropole. But usually these Acropole are with without reinforcement. This is, I can remember once we have designed for around 21 tons of load, but it can be different sizes, but they have purposely designed without reinforcement to last there. So if you can avoid reinforcement, at least for some of the structures, then this concrete will last long. This is my first message. So of course, you can't avoid reinforcement in structural engineering, but wherever possible, so you at least reduce use of reinforcement. This is the first reinforcement structure in the world. This is 120 years. So then if you use reinforcement, so actually concrete is like our body. So because we are going to design for 100 years, so then we should imagine that okay, how we can do it. So like our body. So why you don't resist for say, at least 70 years? Because you get some of the issues from outside. So you have to protect your concrete from outside. And there will be some issues inside there, like cancer in our body. Concrete. But today we are not going to discuss about all the durability, what are the type of durability. But I'll tell you how you can design concrete structure to last for most of the durability. So that's my main. So this is reinforcement concrete 120 years ago. So concrete is in the world used 30 billion tons. So this is, no one can avoid this material. It's one of the material which is used afterward as a construction material, the highest one. So if you in the world, if you take almost all the structures, major structures have been either concrete or composite. This is the tallest building in the world, and it's very recently done. So 2015 done. The second one is very recently done, 2023. is concrete, steel, composite. The first one is steel or concrete, which is called Burj Khalifa or the Burj Dubai. It's a tallest building to last 16 years. So we can discuss about concrete shall be used in structural structure. Then you will imagine that why they are different materials. So in Sri Lanka also we have similar structures. So this is the history around 100 years back. No one thought that you can build structures with concrete, especially high-rise. But later, with the development of concrete and chemical, and people go into more concrete, and nowadays more composite. But only thing is, you have to design concrete in a way that to last. So this is where high performance concrete comes in. So if you have a question, so what is high performance concrete? It's very simple. So what is normal concrete? You get cement, fine aggregate, coarse aggregate, water. And of course, you can add some other material, maybe fly ash. But when it comes to high performance, of course, you add fly ash, then silica pure can be slag. In Sri Lanka, we don't have slag really. And actually, some of the countries, they add fine brown mineral. So even though we don't like, so I think you don't like corridors, you know. Nowadays, you allow to use manufactured sand or corridors in concrete. But if you recall back 10 years back, no structural engineer allowed to use some of these materials. They want virgin sand. How do you have it there? So some of the countries they add finely ground material into concrete. So as an example, cement blend is around 3,000. Okay, this is a number. But this fine material blend is around 6,000. Even double the fine like cement, they add this material to make the concrete dense. So it can be nano material. So likewise, we can work. So we will see. Okay, first of all, we need to understand what are these physical properties and chemical properties. Then how much we can add and what are the optimum levels. So that's what my main frame is to do. So here, if you want to make structure to last 100 years, of course, you have to go back to basics. Just basics only. So you go back to basics. Take that page is. Maybe before. Okay, we go next slide. So okay, then we know that in concrete is very simple. You make it tight, so that is why we need very importantly need to be careful. So we need to know about cement and fine aggregate, coarse aggregate, of you get locally, fly ash, slag, microsilica. So first of all, in Sri Lanka, so I just tell you cement process. So whatever the type of cement you make, first you need limestone. Then you have to go in this process up to here, up to the clean level. Then you get the clean. So in the cement production, you have to have clinker. Just to have clinker, you need limestone. You have to burn it. Then you can make any type of thing. So this is clinker. Then if you don't put anything, we call OPC. Anything means that actually you have to put gypsum. Anyway, in all the cement you need to have around 4%. Plus, actually producer has been given he can add around 5% minor additive. Anything he can add, but just 5%. So this is we call OPC. Basically clinker plus gypsum plus 5%. So we don't want to discuss from here onward, 5% minor reduce, anyone can add, and gypsum always needs that. So then the second type is PPC in Sri Lanka, which we call blended hydraulic cement. It can be fly ash, slag, or pozzolan. So here you can add up to 35%, either fly ash or slag or pozzolan. Only one material at the time. Third, in the limestone, PLC, SLS 1253, you can add up to 20% limestone. The fourth one is SLS 1697. This is composite cement, recently launched, from I think 1 year back. This is, you can add up to 35% fly ash, slag, pozzolan, or limestone as a mix. That's the difference. So I think, first of all, we can clear the cement. We have only 4 types in Sri Lanka: PC, PPC, PLC, and PC. The differences are like that. OPC is only 5%, only clinker, as I mentioned earlier. Then the other PPC is 35% fly ash, slag, pozzolan. Limestone up to 20%. The composite cement, you can add 35 up to 35% fly ash, slag, pozzolan, or limestone. There is a limitation of limestone. You can add only up to 2. So because you are going as a mix, so you can go maybe 20% fly ash, 15% slag, or like that. So these are available in the market. In Sri Lanka, we have one more standard. It is SLS 515. It's a mason cement. No one produced that cement, which is used only for the mason. So whatever name you get in the market, it can be different brand name, but some should come under this pocket. So cement is clear. So if you want to know more about cement, you refer the ESCN 1971. This cement is standard in the world, European standard. So they talk about 27 types of cement. But in Sri Lanka, most of the cement we have derived from them. So this is where we have position. This is when I was in cement. So we had this OPC and we had this Holcim Extra, that is 21% fly ash, which is used for lotus cover. And in between, we found that we can find another cement with 6 to 20% fly ash, which is good for high-rise building. I tell you what. So this is standard. If you want to refer, this is you can download from the Google EN 1971 2011. The later versions are there, but downloadable one. Okay, if you go back to the material that we can add into concrete is like it can be fly ash. So this is not the power plant. This is what you see here is coal yard. When you burn this coal in the power plant, you get fly ash as a byproduct. So what you see here is the bottom mass. It's yard, so it's no one used at the moment. So there's a huge amount of bottom mass at the North Shore. So this photo has been taken years back. I'm sure this now it's more than this. So if you clarify ourselves what is bottom mass and what is fly ash, very simple. In this burning process, whatever flies out is called fly ash. That's why you go to fly ash. So go out from with the emission, then you have different text you take it, we call it fly ash. So obviously this is very finer and this is very comparatively pure material. Okay. What you get in the bottom, we call it bottom ash. So the right side down bottom is bottom ash. So this is with very low purity, unburned carbon, etc. So if you see both structures of these, it's completely different. So you can see top one, this is from the scan electronic microscope. So you can enlarge it and see it. So fly ash said to be that always spherical in shape. Spherical. But bottom ash is like, it's like aggregate kind of thing, like sponge kind of. So, and it is many. So if you use bottom ash, I don't say you can't, but you need to be very careful. you need to have a chemical. So fly ash still can be used in Sri Lanka. So then second, as structural engineers, you should know there are two types of fly ash. One is class F, other one is class C. Okay. So F and C come because of this mineral composition. Usually, if you want to use fly ash for durability purpose, you have to use class F1. Class F. So in Sri Lanka, we have class F1. I tell you what are the difference. Usually, class C fly ash, you have no calcium oxide. That's the issue. So it's good, you can add it, but if you want durability, if you want to delay your strength gaining, likewise, you need to go for class F1. Mostly in Sri Lanka, imported material, and the material you locally buy is in the class F1. So we can forget about class C for the. So this is spherical shape. Then when we discuss about material that we can add into concrete, we can categorize into three. Very easy. First type is latent hydrogen. Mean this material, when you mix it water, there is a reaction. Not like cement-like reaction, but there is a reaction. So this is we call slag. Slag is the latent hydraulic, hydraulic SCA or the material, mineral energy. The second type is pozzolanic material. There's no direct reaction with water, but you can activate it with like material like calcium oxide. The third one is inert filler. Inert filler, there's no reaction. So you can say very limited reaction. So any material that you add into concrete, except cement, coarse aggregate, all other materials come under this category. It is either inert filler or the pozzolanic material or hydraulic, latent hydraulic material. So there also is very easy for us to segregate. So like livestock, it is only an inert filler. And mentioned that actually there's a limited reactivity, can be very limited. The other one is slagging, is latent hydraulic, slag reactive water. All other materials come as pozzolanic. So like fly ash can be class C or F, pozzolana, any kind of ashes come under the pozzolanic. So we can divide in these two. Then we should know the properties of these materials. That's the second thing. So if you see here also, now, so if you see the first one is slag, is like what you see from the scan microscopy, so enlarged one, it's like aggregate. Okay. Second one, fly ash, what you see is, as I mentioned, spherical. So if you go further, this material, when you add slag into your concrete, workability will go down drastically. But if you add fly ash into your concrete, because of the spherical shape, it enhances your workability. So that's why wherever you need more workability, fly ash is highly recommended. Really. So other material like pozzolanic material, they are flaky, so likewise. So this is in the same thing, so I can avoid it. So if I just tell you clinker, so there is a fast reaction, slag, very slow reaction, fly ash, no reaction. And fly ash plus line, there's a reaction. So this is what I told you. Cement has a reaction, slag has a very slow reaction. All the pozzolanic material react when there is a line in your mind. So that's why in the past they have used, always they have used as with line. Because you need to activate any kind of ash, you need to go with line. If you can play this. Okay, no, forward. So this is same thing is shows here. Flat, you need to have water, then the activator. Portland cement, you need just water. And the pozzolana, you need water plus lime. This is how we are doing. So from everything you produce, we call calcium CSH, calcium silicate hydrate, which is responsible for it. So if you have cement, you can just have water, then you can have the strength concrete. So if you have pozzolana, if you add in a way that lime into it, you can have concrete. So this is we call geopolymer concrete. So different word can be used, but any ash can be activated with lime. So flat also similarly, you can go with activator. So this is very small concrete particle. If you see through the scan electronic microscope, it looks like this, like a jungle within the concrete. So what you see here is a very small one. Then you have to gold coated or the carbon coated. Then you put it in the machine. When you see it, like when you check your blood, what is inside, you can check it. So this is inside concrete. So you can see the magnification is 5,000. So it's like a jungle. So it's like a X-ray. Actually, better than X-ray because this is a large one. Then whoever who knows about concrete can tell us what is inside, so what is going to happen. So like that. I'll show you a very good example. So this is nano line, and this is fly ash. I told you this is spherical. So this is during my PhD. I have done myself. So when you enlarge it to 6,000, so you can see all the particles are spherical. Then there was an argument that at that time you were producing and promoting fly ash blended cement. So most of the engineers used to say that when you intertwine this fly ash in cement, it breaks. So it's a very good argument. So even actually at that time we check it. So even in what you see in the bottom, you can see spherical particle. This is fly ash blended cement. Spherical particles are there, but I don't know how many percentage is exactly. But you can see spherical particles, reasonably spherical particles are there. So that's why it's promoted for working. So with the development of chemical admixtures, industry has gone into different level. Actually, Mr. Param in the second session, he will discuss about chemical admixtures. And especially today, he will stick to the waterproofing in the basement area. But he will just tell you about both of the admixtures. So this is the concrete specification, BSCL 206. So there's a complementary specification as well. So if you want to know anything about concrete, this is the specification need to be followed. So I tell you, even though we have thousands of specification and all other, in concrete, always basic matter. That's it. Nothing else. If you stick to basic, you can make wonders, you can make structures. I'll show you why. If you go your water cement ratio beyond 0.5%, no point of discussing durability. There's no point of discussion. So this is in the graph it shows that. So of course, in general construction you have to go 0.5, 0.6 likewise in maybe normal house construction. But if you make a structure to last, you should bring that water cement ratio to at least 2.4. Otherwise, it's no point of discussion. Plus, always we, as I previously mentioned, when you add reinforcement into your concrete, we assume that your concrete is homogeneous. All your calculations you assume. So you have to make your concrete homogeneous. That should not be honeycomb and all others. Of course, there will be, but at least you have to protect your reinforcement. So, most important area when you add reinforcement in concrete is cover. That's very important because you have to protect. It's like our body, you have to protect all the things outside. You have to protect it. So you need to have very good skin in your concrete. So all these theories tells you same. So this shows in different ways how it works. So you have to reduce permeability in your concrete, and of course it will increase durability. So, but we'll see. So as I mentioned today, we are not discussing about what are the different durabilities. But if you reduce permeability, water permeability will be low, RCPT will be low, all the material bring into the concrete will be very low. So you can see in this also, except, so these are the durability classes according to EN 20. It can be no risk. Of course, if there's no risk, you can do as you wish. But as I mentioned, so because if you don't have reinforcement inside, most of the time, water ingress will not be a very critical thing to happen. Of course, there are some other issues, like we get different diseases in our body, but main issue is corrosion. So there won't be any issue. The second one is carbonation. In the carbonation, why you are allowed to go up to 0.6, 0.65, etc. Because the carbonation depth per year is around 1 millimeter. So you have a 50 millimeter cover, just to reach there, it takes 50 years. So that's why sometimes you have been one little bit of release. But if you have seawater, corrosion induced by seawater, then you see the water cement ratio are limited to 0.5. So other than seawater also sometimes you have maximum 0.5. Then freeze pro, we don't have much here, but both heating and cooling is very much similar to that, but we don't go into that extent. And aggressive chemical, these are the most common ways. So these are the recommended, the maximum. You have to be below 2. That's why I told you that if you want to design very good structures, please be around 0.4. And second is the minimum strength class also you need to be careful. What are the minimum strength classes? Then the minimum cement content. Of course, sometimes you don't worry about the maximum cement content. Maximum cement content is also very important. I'll show you a very good example. You should stick to below 550, which most of the standard. So all these standards tell you the same thing. ACI, similar parameters are there. So I don't want to discuss in detail. So I don't know whether we can tell you. At the end of the time, we over. So now I'll show you these applications involved. So then we can stick with and we can see how it's going. So this is Burj Khalifa. It's in very aggressive environment. You can see the location is you have almost all the aggressive. So as I mentioned, we don't want to divide into the different aggressive issues. We will address as a whole. So as a body. So we will make our body very robust. Then no disease can come. So like same similar approach. So this is Burj Khalifa. So this is pipe foundation. Now I told you that okay. Now we need to imagine. So what are the materials that we are going to add? Flat, fly ash, limestone, OPC. So in Sri Lanka, 20 years back, everyone liked OPC, including structural engineers. So if you are given Burj Khalifa, they have enough money. So if you are given to choice, so what material do you use for pipe? You have only choice OPC because or fly ash with OPC because they are okay. One more thing, in different countries follow different standards. Like countries like Sri Lanka, we add all this material most of the time into cement. Country follows the American standard, they add all this material on site. Get OPC at fly ash, get OPC at flat. So either you can add into cement. So in this case, this is a Dubai. They mostly go with American type of standard. So they have added all this material on site. Okay. Now we have option OPC or OPC plus fly ash. If it is fly ash, what is the percentage? Or OPC plus slag. If it is slag, what is the percentage? Or microsilica, what is the percentage? Or limestone, any other material, you can name it because they have enough money. This 10 million project, so US dollars, they will use it. So what is your recommendation for pipe? So if but okay, as a contractor or the anyone, if you want to fix it in advance, you don't see it in the below. And workability really matters to you, isn't it? Workability really matters because the ground, if everything flows, it's self-compact is really good, still work very well. So what material you use? This is the best material is fly ash. So this is the reinforcement structure. So I don't want to explain you in detail. So this is the process, but this is they have used this combination. This 23% fly ash plus 7% microsilica. So then our question is why 23%? Why microsilica only 7%? Because just to have durability, if you use fly ash, at least need to have 25% only fly ash. But when you use combination of this microsilica, is around above 25% will give you very high durability plus strength. So that's why they have gone with microsilica to get required strength and the workability and the durability with the combination of these. So that's why they have gone 23% higher, not 10%. Now this is done. Second one, file cap. What is your solution? Now you can, it's easy. So we have done one. What is your recommendation? OPC, fly ash, or slag? What do you think? In this case, as Mrs. Romal mentioned, you can go for fly ash, but they have used slag. One thing is, workability is not a critical issue because it's a very big area. spike caps are quite big. So you can go it and density. So then, of course, durability is there, especially for the durability, either you can go with fly ash or slag. Of course, always with microsilica to get the strength plus durability combination. So always they are gone with 7% microsilica most of the game, 5 to 10%. This is they have used slag. So why they have used 57%? Sorry. Yeah, exactly. This is for the thermal effect is there. Then actually you don't want strength early days. If you get it, it is an issue. So these are very big pile caps. And of course, this pile cap will be used after 2 years in full strength, full load and all others, maybe 1 year. In that case, you need to add very slow strength gaining curve. So that's why they have used slag. Second thing is, if you use slag instead of fly ash, usually in general, you have used double the amount of fly ash. Say 25% fly ash if you use for the durability. In slag, you have to go 50. These are all the thumb rules, but I am telling you as engineers, you should know only the thumb rule, then whole standard will tell you different things. But if someone comes and tells you that in their cement, they have had 20% slag and this is very durable, so it is not true as this. That's what we have. It's you need to have at least 20-25% fly ash in that category. You add slag about 50. Fly ash about 25. So these are the things that we need to take into our mind. If you want durability, yeah? But if you want strength, it's different thing. And microsilica always, all the standard limit at the 11%. So usually 5 to 10% is the very good area to use. So second case is over, third one. Now we are going to pump your concrete up to top. They have pumped up to, I think, around 500 meters. Although this is 800 meters, so 600 meters. I saw there's a photo with Professor Rian at 600. So now you are going to pump this concrete. So what is your material? Fly ash. Fly ash. Why the amount is low? Because the durability issues are not much there. Second, if you add more fly ash, strength goes down. So durability issues are not critical because they are at 18%, 18 plus 9 mean 20 plus mean durable. But you need to have certain strength. Strength is the critical one. So this is all the columns and all that. And you should be able to pump the concrete. So you can make the best concrete maybe in the lotus tower on the ground floor. But if you want to pump it to 300 meters up, it's a different case. Then you have to work on different workability and everything. Of course, what I am telling is only this material, but they have used a lot of admixtures, which I'll show you later. But technically, if you want to use this material, so this is the general guide. So this is the complete this design which is used for Burj Khalifa. As I mentioned, you see total cementitious material, not only cement, cement plus all other material. Total cementitious material is less than 550. So wherever we use above 550, of course there won't be any issues in nearby, but will not last. So that's why you need to reduce it. Can see fly ash is in between 10 to 24%. And microsilica 5 to 9%. So actually these are the things that we need to get into our mind. So just thumb rule. As engineers, we should know where these values are moving. So as an example, as a doctor recommend Panadol for the particular way. You should know the tablets you need to take. Should not be 10 over the quarter. So that is even players when you add it, as engineers, you should be able to recommend. So this is the complete mix design of the Burj Khalifa, which is available in the internet. So you can see the amount of admixture they have used is very high. Usually you use 1% of the cement in admixture, usually. But here they have used up to 3%, 4%, sometimes when the 7%. So even though I show it very nicely that when you add fly ash, it's flow up to 600 meters, doesn't. But with the admixture, with the fly ash, it goes. So that's why you can see in the Burj Khalifa, they have used, this is grade 8 concrete. You can see how much cement they have used. Only 400 kilograms. This is OPC. Plus fly ash 100 and silicon 50. Altogether 500. And they have gone admixture 3%, water cement ratio 0.3. And of course, aggregate size they have reduced up to 10 millimeter because you have pumping and so this is, as I mentioned, even though there are 100 standards, if you stick to basic, you can make things last 4 years. So I think I'll go fast. So how many minutes more I have? 5 minutes. Okay. Okay. 5 minutes. So this is some of the structures. Total structure, we have used 25% fly ash. So this is very good photo. They have taken. Siroma is there. From the Nara from the This is what I told you in the mass pouring. So in the mass structures, you need to stick to 2 things. One, the temperature at any given point should not exceed very roughly 70. And the temperature gradient should not exceed 20. So means that the concreting in Nuwara area, mass pouring is much difficult than in town. So the surface temperature is very low. The gradient can be higher in Nuwara. So I don't want to go into detail. So mass pouring, you have to do. So you can do concrete modeling. I think some of the cement suppliers they have. So you can model your concrete and see what are the strength, temperature. So you have different challenges. So I think this project they have used fly ash and cement manufactured sand. So now, not like earlier days, people will come and ask you whether you can use CSEC and manufacture sand, fly ash, anything which is available to be used in the future. So this is kind of the structure. So as engineers, what we face is architects draw different drawings. So but as engineers, we should be able to build. When we build a vertical, they want to rotate it. Then when you rotate it, sometimes you have to make it turn. You turn. In the future, we don't know where it goes. So we have to ready for it. So with that, just the future of the construction is sustainability, where we have discussed all these. I omit them because we have limited time. So as instruct engineers and architects and all other departments here, I will ask you to use as recycled material as possible, like in this building. So you can use anything in your home. So as an example, I think he has used hair, clothes and all that. Even in the past, when we don't have anything, they have used horsehair in concrete because it's good to tension. It will not give you surface cracks because you can use just hair. We have a lot of hair, enough hair from salon you can collect it and use it. Because I don't have, I don't like it. So this is one project in Singapore. This is garden by the way. They have used 20% recycled aggregate, not of course for the critical element, but other element just to get green level. Sri Lanka also same. precast is the future, because I have been given 5 minutes. And this is PPVC is going on even in Sri Lanka. Very happy to see that this is the future. So this is exact one I took around 10 years back in Singapore. And ultra high performance concrete comes to the picture. Ultra high performance concrete, the maximum size of aggregate is 2 millimeters. So even though you say it's concrete, not concrete, but we call ultra high performance concrete. It's like toothpaste like material, which gives you 150 MPa. It's really good for this kind of cladding and all of this. And this is exact sample I checked in Malaysia, because they have done this structure in France when I was working with them. So we can go on fiber reinforced concrete, self cleaning concrete, floating concrete, so pervious concrete. So likewise, can make a different way. Can make tent-like material. So this is actual structure. So when your architect comes and tells you that I want my concrete like tent, you have to accept it and you have to do something. This is facade. Some of the facade, concrete facade is very popular. So in the structure, 3D printing has come into action. You can make concrete even transparent. So with that, thank you very much. But I think before I conclude, I will give you few slides, as usual. So if you forget about concrete, it's okay to break rules. So I think Kiroma will not agree. But I feel that break a little bit, somewhere. Then you can enjoy it. So be a legend with others to inspire. This is how I was work as chairman. So I think I was the only chairman who were follow the speeches, but in the evening. So life is not meant to be too serious. So forget about the concrete. Enjoy today. Enjoy this moment. Enjoy the evening. So if you can sleep tonight very well, so you are done. So one life, live it. So it's not meant to be too serious. So wherever possible, to find the joy was. Work hard, play hard. So be with your team. They raise you. Please remember that. It's very important. Without the team, you cannot be a leader. Nowhere in the world has been a leader without. So you have to. If you can make your team bigger and bigger, you will become a better and better leader. So that's very important. So be with your team. That's very important. At last, be with your loved one. They are the biggest thing. So thank you very much.
Thank you, Dr. Shravan, for that very informative presentation on high performance concrete. You also elaborated on how we can use in mega projects, and then talked a little bit about the sustainability side as well. So with that, we will now I would like to take this chance to introduce Professor Priyan Mendes. Professor Mendes is a professor of civil engineering at the University of Melbourne, and is internationally recognized as one of the world's leading experts in structural engineering. He's also the founder chairman of the Green Building Council of Sri Lanka and the honorary chairman of both the Civil and Structural Engineering Consultants and the Structural Design Institute SDI. He currently serves as the director of the ARC Center for Advanced Manufacturing of Prefabricated Modular Housing. And throughout his distinguished career, Professor Mendes has contributed to the design of globally recognized projects, including the Burj Khalifa, Merdeka 118, and Eureka Tower, and major infrastructures such as the Sydney Harbour Bridge and Melbourne Metro Tunnel. His research contributions include over 550 publications and 24,000 citations. The world's researchers in structural engineering. So without taking time, since we are running a little late, let me introduce and hand over the controls to Professor Priyan. Over to you, sir.
Thank you very much, Andrea. Because we are running late as well, so we want to. I'm following an excellent presentation from Dr. Tushar. I was listening to that presentation later, and I just want to say thank you for the audience. I've been actually, in fact, invited to talk in this one of the conferences in Sydney. So my topic was the barriers for getting to net zero, and especially my concrete career goes back to about 35 years. So the concrete is one of the main polluters, but also part of the solution. So that's what Dr. Tushar was trying to present with case studies, the basics to finally with the Burj Khalifa type of examples, trying to say why we can really design the 100 years. That's what he was trying to say, getting the high performance concrete. So we had excellent talk. So I will not elaborate on too much, but I think that issue, because the main material that is concrete we talked about. So we are so many different materials we work on, supplementary cementitious materials. So these further talks from the SDI, this is one of the first to start with, and I think we will elaborate a bit more on the recent developments. And today we were just talking about, my talk was based on so many different new the supplementary cementitious materials such as cast and clay. We are working on lithium slag, and also my group is working on the blended and so on. So also we are doing some predictive modeling and all that. So it's very complementary. And following on from Dr. Tushar's talk, we have very good talk from Mr. Parameswaran, who has got so much experience and working in Middle East for so many years, and also for the leading Fosroc India. And there's no better person than him to talk about the waterproofing. So I'm looking forward to listening to that talk from Mr. Parameswaran. And these are two very important areas. And I'm sure at the end, there could be some questions from the audience. So I will not take time because we all want to, after listening to a very excellent talk from Dr. Tushar, we want to listen to Mr. Parameswaran. And also, thank you, Mr. Shomal. Actually, he is the leader of the CSEC group. He joining this talk, and he's got so much experience. So I think we really admire him joining this talk as well. So, and also every participant. So thank you very much. Also, thank you to Engineer Andrea for really coordinating this very, very, very informative, very important seminar, because we want to design for structures for 100 years. 50 years is not enough. Now, we have been designing structures, buildings for 50 years, infrastructure for 120 years. But we want to, in the future, look at all buildings to be designed for a longer life. That will be the most sustainable if you design for a longer life. So thank you very much, everyone, and hand over to Engineer Andrea to really introduce Mr. Parameswaran.
Thank you, Professor, for that introduction to this speakers. Despite your busy schedule, you took your time to join us today, and thank you for that. And let me introduce our second technical presentation resource person, who is Mr. V. Parameswaran from the Fosroc India. He currently is serving as the product segment manager for roofing and sealant at Fosroc India. So Mr. Parameswaran is a civil engineering graduate with more than 31 years of experience in the construction chemicals and building materials industry. Having spent 26 years with Fosroc, including extensive experience across the Middle East and India, he has developed deep expertise in specifications, product management and technical services, marketing and business strategy. His current role at Fosroc India, he leads the waterproofing and sealant product portfolios, driving product innovation and strategy while using technical excellence with commercial success. Please join me in extending a very warm welcome to Mr. Parameswaran. Over to you, sir.
Hello all. Thank you, Dr. Mendel. Thank you, Dr. Tushara, for the nice presentation. So first, I will share my screen. Hope you're able to see my screen, right? So welcome you all to this presentation on substructure waterproofing system. Actually, Dr. Tushar talked about the concrete, designing the concrete for 100 years, and he also talked about the various, cement replacement materials and all that. But when it comes to waterproofing, it is basically a system which is, done as a barrier to prevent, any kind of water ingress into the concrete. And so the basic necessity for providing this system is to enhance the durability of the concrete so that the concrete, serves its purpose for the design of its life. So this part of the presentation, I will giving a small introduction about our company because we represent industry which manufactures the waterproofing products and all. And then I'll give an introduction. I'll give a briefing about why do we need to waterproof the concrete structure, and then there are we'll touch upon some of the the international standards which are used for designing the waterproofing system, and then what are the different products and solutions that are available for the substructure waterproofing. So today's presentation is mainly focused on the substructure waterproofing, on the products and solutions that are used for protection of concrete against water ingress in the below ground structure. So just a small briefing about the company. We are from Saint-Gobain Group, which is a French conglomerate with a very diversified business interest. And this company is present, this group is present in more than 80 countries worldwide with, total employees about 160,000 employees. In the year 2025, we achieved a return of about 47 billion euros. So when it comes to the construction chemicals, there are various brands under the construction chemicals business unit of Saint-Gobain. So we can see from the brand here, we have more than almost 12 companies which are specialized in their respective product group, and all these companies basically comes under the Saint-Gobain business unit. When it comes to the Sri Lankan market, we have the Criso and the Fosroc. Fosroc was present in the market some time back, but now this market is scattered from India. But now Criso Sri Lanka is the company under which all these brands will be promoted in the Sri Lankan market. Now, when it comes to the construction chemicals portfolio of the CCB or the construction chemicals business unit of Saint-Gobain, we offer a very comprehensive product range for the various applications in construction industry, whether it is for the building or infrastructure or for energy or for any other application. We have more than 500 products which are broadly classified under 12 product segments. And all these products, we offer a very comprehensive solution for the for the construction industry. So I'm not going to talk about detail about all these products, but because due to the shortage of time straight away, I will jump into the topic for today's discussion. So when it comes to waterproofing, for the substructure waterproofing, basically for any waterproofing in concrete, first we need to know why we need to waterproof the concrete. Is it really required to waterproof the concrete? So there are some reasons, some important reasons why concrete structures require waterproofing. So one is that the concrete is not always impermeable to water. Like when during the discussion of Dr. Tushara, we came to know that one of the important tests for measuring the impermeability of concrete is the water permeability test. Because see, when we do a concrete mix design, basically what we do is we design the concrete at a certain water cement ratio. So if you take a concrete mix, the water cement ratio that is required for the complete hydration of the cement in the concrete is 0.27 or 0.26. But it is not possible to work with a concrete with such a very low water cement ratio, because the concrete workability will be very low in that case. So what we normally do is we add some extra water to the concrete to make it more workable, and eventually that water will leave the concrete after the hydration process is completed, and it leaves some small voids and pores inside the body of the concrete. So when this concrete is subjected to any kind of a hydrostatic pressure, there could be a water ingress into the concrete. So it's very important that we provide some kind of a barrier on the surface of the concrete, which will prevent water ingress into the concrete due to hydrostatic pressure. Second is the bad workmanship or quality control issues and the honeycombs or voids that can, come in a concrete structure. For example, it's always not possible to make 100% perfect concrete structure. Sometimes we end up having some kind of a defects such as honeycomb, voids, or some kind of any kind of aggregate finishes and many other defects in cracks, something like that, many other defects in the concrete structure. So these defects will become a potential point for the water ingress into the structure. So it's very important that we have to prevent the water seepage by providing some kind of a barrier system on the concrete surface, which is basically done with a waterproofing system. Also, we know that the curing of concrete is an exothermic reaction. It releases a lot of heat. So when we do the concreting works, particularly for the bulk concreting works, where we need to construct a raft of thickness about 3 meters or 4 meters, or roof slab, very thick concrete. So it's very important we control the temperature of the concrete. If the temperature of the concrete is not controlled properly, what will eventually happen is that it can develop the micro cracks within the body of the concrete due to the heat of hydration, and these micro cracks will become a potential path for the water ingress into the concrete. So this cannot be avoided in many projects. So for that reason, we provide some kind of waterproofing barriers in the concrete. And then the construction process itself will create a lot of weak areas in the concrete, like we have the construction joints, the tie rod holes in the concrete. There could be some expansion joints, which are design joint in the structure. So those areas are also a potential source of water ingress, which needs to be properly waterproofed to make the structure completely watertight. So when it comes to the substructure waterproofing, it's very important that we follow right principle for it. So I would call this as a drift approach, meaning that it is do it right the first time. Because see, what happens in substructure waterproofing is that it is unforgiving. Actually, if you do any kind of an error or a mistake, if you don't select the right waterproofing system, it is very difficult to redo the waterproofing, because once the structure is waterproof and you have waterproofing treatment outside, particularly in a basement structure, once it is backfilled and all that, if the waterproofing system fails, so it is not possible to remove the backfill and then redo the waterproofing there. So the only option is to provide some kind of a treatment from inside, which will not be a full 100% watertight system. So when it comes to the substructure waterproofing, we must follow this drift approach so that the right waterproofing system is selected and we do the right waterproofing at the first time. So how do we do this? Prevention over correction. So quality has to be built in the design, in the initial phases itself, and then the clear requirements, all the specifications and the standards and the customer needs should be fully understood before execution of the work. And then we have to follow the right method statements, like the inspection test plan, the method statement, the shop drawings, and every detailing needs to be properly done before starting the work. And then we have to ensure that the work is done by a properly trained applicator. So all this, processes are very important when it comes to the substructure waterproofing. Now, when it comes to substructure waterproofing, as far as the standards are concerned, there is a standard, which is very widely commonly used all across the world, which is BS 8102. And this is a standard which provides some kind of a guideline for selecting the right waterproofing system for a substructure waterproofing. So, as per this system, it basically assesses the risk of water reaching the structure, and it provides some kind of a guideline as to how or what needs to be done to select the right waterproofing system for a substructure waterproofing. So here, it starts with basically the site inspection and the data collection. For example, if a substructure waterproof, whether it is a tunnel or any kind of an underground structure or a building basement, what is the most important thing is we need to carry out the site inspection first, and the data collection is very, very important. So it talks about to assess the hydrogeology and the geology of the area. Basically the soil type, which is very, very important, because different types of soil, the behavior will be different, the foundation design will be different, and we need to ensure that a proper waterproofing system is chosen for that particular soil type, so that it remains robust, and any kind of movement or settlement that may happen in that structure, the waterproofing system should be able to withstand it. And then we need to evaluate the flooding risk in that area. Flooding risk, I would say that in some areas where the groundwater table level can, it can rise and can come down during rainy season, or you could be constructing a structure which is very close to a, ocean or to a river or to near any water body. So all the possible risks of, water coming in direct contact with the structure must be properly evaluated during the site inspection. And also, like I mentioned, that all the external sources of water also need to be properly documented. And then the next one is the determine the site usage in the building type, for what purpose the substructure is going to be used for, whether it is a basement structure for a car park, or it is a structure which will be used for a storage area or some kind of a restaurant. So the usage of the building of the basement structure, for what purpose the basement structure is going to be used for, that needs to be properly established. Once all this is done, then we assign the site water, the water table classification as per the BS 8102. So it says that there are 3 types of water table that can exist in the area. Based on that, we need to select the right waterproofing system. So the code recommends 3 types of waterproofing: type A, type B, and type C. We'll be discussing about that in detail now. So once the proper analysis is done, the site inspection data is collected, then we can frame the right or make the right specification, select the appropriate material for that particular situation, and then we can submit the report for the consultant or client approval. So some of the basic, actually, if you see that the BS 8102 is a code which got revised in the year 2022 again. As per the latest revision of the standard, the most important recommendation is that the waterproofing system, what is being used for the substructure waterproofing, should be a fully bonded waterproofing system which bonds to the freshly poured concrete. So this is very, very important. We will discuss that this particular recommendation in detail in the next slide. And then it also says that even if there is no water present at the time of construction or during any kind of a survey, it is always good to consider some kind of a water pressure, because many things can change during the service life of the structure. The water level in that area can raise up, it can come down, or the hydrogeology of the area can change. So that is always good to consider that even if there is no water pressure in that area, we must consider the minimum water pressure of 1 bar while designing a waterproofing system. And all that importance should be given to any kind of anchor piles and props and valuing beams, pipe penetrations, construction joints, all that particular proper detailing needs to be done in the waterproofing design. So there are three important considerations for selecting the right substructure waterproofing. One is the groundwater table level and the intended use of the basement structure and the construction method. So the classification of water table is that high, low, and variable. High water table level is basically the level which is below the base slab of the structure or the raft slab. And the low water table, the low water table level is something that below the base slab of the structure, and then the high water table is a permanent water table level above or at the level of the base slab, and then the variable water table level is the one which fluctuates during the seasonal changes and all that. So the standard is that you must always assume some water pressure from ground saturation if there is no water present at the time of survey. So coming to the basement grades, the standard recommends three types of grades. So depending on the usage of the basement and what degree of water tightness is required for the particular type of structure. So whether it is a car park where some kind of water and damp areas can be tolerated, or if it is a ventilated residential commercial area, an absolute dry surface will be required in many areas. So depending on the basement, depending on the utility or for what purpose this basement is going to be used for, we need to select the right waterproofing system. And also it talks about the construction method. So because when it comes to the basement construction, there are different types of construction techniques that are used. We know commonly about the bottom up and the top down approach. So in some cases, the basement structure is constructed with some kind of a working space between the excavated surface and the retaining wall. You can see here. This is basically called unconfined basements where you can do the waterproofing and then you can do the backfilling. In some cases, these are called the confined walls where the total boundary perimeter of the plot will be used for the construction. In this case, the waterproofing has to be done against the shoring and the basement wall will be constructed with a single side formwork. So depending on the type of the construction methodology that will be used for constructing the basement structure, we need to select the right waterproofing system, because the waterproofing system which is used for the unconfined location cannot be used for a confined location. So selection is very, very important based on the construction method. So when it comes to the basement construction, we have different types of soil retention system. Basically, these are the retention system, or these are the methods by which the basement excavation is done. So the most commonly used is the diaphragm wall as well as the thickened piling. So this is the first activity, depending on the soil type, the depth of the basement, and many other factors. We need to consider which kind of the retention system has to be used for the constructing a particular basement. So the standard recommends the three types of, based on all the survey reports and all that. We need to select the right waterproofing system for the basement. So there are three types of waterproofing system that is recommended by the standard: type A, type B, and type C. So what is the type A waterproofing? A type A waterproofing is basically a waterproofing system which will be done on the external side of the basement structure. So here we are providing some kind of an envelope, or we are completely encapsulating a structure with a waterproofing treatment from the external side. And in type A, we have the sandwich waterproofing system also. Basically, this type of system where you have some kind of a diaphragm wall, and then you're constructing a retaining wall against the diaphragm wall. So the waterproofing system will be sandwiched between the diaphragm wall and the retaining wall. And then we have the third type of waterproofing, which is an internal waterproofing. So here you can see that the waterproofing system is applied internally, because if there is no external waterproofing in this case, and or if the waterproofing system has failed, so there is the only possibility that you can do the waterproofing from inside. So this is called the internal waterproofing system. So the type B system is basically an integral system in which we are trying to make the concrete structure itself waterproof by adding some kind of a chemical admixtures to the concrete. And then here only the joints will be treated. For example, if you have a construction joint or movement joint, so all the joints will be treated with some kind of a water bar or a PVC water stop, so that the structure remains watertight. So here the procedure is that we have to design a concrete with a very low water cement ratio to produce for an integral waterproofing for the type B system. A concrete mix has to be designed with a very low water cement ratio. So once we reduce the water content in the concrete mix, what happens is the voids and the pores in the concrete will come down. And then in the same concrete mix, you add another admixture, which is basically a crystalline admixture, which will react with the products of cement hydration and form some insoluble crystals inside the body of the concrete, which will seal all the voids and pores inside the concrete. So when it comes to the type B system, which is an integral waterproofing system, it's a combination of two products. The first is a high range water reducer, and the second is a crystalline waterproofing compound. And there are the third type of system as per the standard, the type C system, which is the drain basement. Sorry. So this system, normally what is done is some kind of a drainage layer is provided on the external side of the basement or internal side, so that any water pressure that is coming on the structure, it will get into the drainage layer and get drained to the perforated pipes, which are placed in the soil below the retaining wall. So those are three types of the waterproofing system as per the BS 8102. So depending on the soil conditions and construction methodology and all that, we need to select the appropriate waterproofing system for the structure. So that was a briefing about the standards, the 8102. Now I move on to the products and solutions that are for that is available with Saint-Gobain Fosroc for the substructure waterproofing. So when it comes to substructure waterproofing, it is not only the treatment for the retaining wall or the base slab. So it has got many components in it. You can see in the slide, there are, like, when it comes to the retaining wall, we have different types of walls, confined wall and unconfined wall. And some cases, even the diaphragm wall is used as a permanent wall for the station. And then there are the piled tops, piled heads, which require special treatment. And then we will have the joints and penetrations in the retaining wall or in the base slab, which obviously the movement joints, construction joints. There could be some earthing rod penetration, rock anchors, then pressure release pipes, and then tie rod holes. So when we design a waterproofing system for a basement, it has to be a very comprehensive design, including all these penetrations, and then the retaining wall and the base slab. So there are three types of membranes that are used for the waterproofing of substructure. The older generation membranes, basically these are the products which are bonded to the non-structural concrete. For example, if you take any kind of a bituminous sheet waterproofing, these products are bonded to the non-structural concrete, because there is a blinding or the PCC layer on which the waterproofing will be applied, and this vertical surface of it could be a shotcrete surface, or it could be a lean concrete, or it could be a sacrificial formwork. So the waterproofing system has to be bonded on a non-structural concrete. So these are the products which are the old generation products, which are getting slowly obsolete now. And then the second system is basically a loose slide waterproofing. So this product neither bonds to the structural concrete or to the non-structural concrete, and it remains as a loose sheet between the structural concrete as well as the non-structural concrete. So this is another type of waterproofing membrane. And the third type of membrane is basically as per the BS 8102 standard, which is a fully bonded or bonded to the structural concrete. So here what happens is this product, when applied on the substrate, it can bond to the freshly poured concrete. And what are the advantages of using a pre-applied waterproofing system that we can see in detail now. So when it comes to different types of waterproofing system, we can see here that there are different types of systems available. There are products which are based on bitumen sheet, and then there are products which are synthetic, membranes, the thermoplastic membrane based on PVC, EVA, and there are products which are bonded to the structural concrete. These products are based on high density polyethylene. Then again, the self-adhesive bitumen membrane is available, and there are polyurea coatings. So here you can see that for what application which product is recommended. So moving on to the pre-applied waterproofing system. What are pre-applied waterproofing systems? So basically, when we see the conventional system which are based on the torch-applied bitumen sheets, like I mentioned, that these products are bonded to the non-structural concrete. Here you can see that it will be bonded to the PCC or to the sacrificial formwork. In the event of any settlement of the structure, what happens is this membrane also will slide down along with the PCC or with the sacrificial formwork, which will result in some kind of a gap or void formation between the structural concrete raft slab and the PCC, and it will compromise on the waterproofing integrity of the structure. So this is one of the biggest risk of product which is bonded to the PCC, and there are a lot of failures we have seen with this kind of a system, and due to which there are new generation waterproofing systems that have come to the market, and even the standard, the BS 8102 also recommends to use that kind of a system. So the system what I'm talking about is basically a pre-applied waterproofing membrane which are based on HDPE. It is fully bonded to the raft and the retaining wall. So here you can see that the waterproofing membrane is bonded to the raft slab or to the retaining wall. Any kind of settlement of the structure, even there is a gap formation, since the waterproofing membrane is bonded to the structural concrete, the waterproofing integrity of the structure can be maintained. So this is one of the biggest advantage. And also these products are very good based on the application ease and a lot of other factors, cost saving, labor saving, many other advantages we can achieve by using this pre-applied waterproofing system. Now, this is one of the products we have, which is called Proofex Engage. And this is a product, again, a pre-applied waterproofing system. If you see the design of this product, it is basically a HDPE sheet which has got a mesh kind of a structure on the top. So when the concrete is poured on this waterproofing sheet, this sheet will get, this mesh structure will get embedded into the fresh concrete, and it bonds to the structural concrete here. So when it comes to the different types of tests, we have carried out a lot of tests for this product. And one of the important tests is we can see here the 125 years service life, which is tested as per the EN 13251. And this test is basically to check the durability of this product for a period of 125 years. And this product is resistant to gas and soil, different kinds of chemical resistance this product has, and also it is a BBA certified product. So this is how the application is done. This is the PCC or the, you can see the blinding concrete on which the waterproofing membrane is laid, and then this is the fresh concrete. This is the cut section of a full slab. So when the concrete is poured on this waterproofing membrane, you can see this, this is a mesh on the top of the membrane, which will get embedded into the fresh concrete and becomes a part of the structural concrete. So this is how the application is done. You have a well compacted soil base or a PCC on which the waterproofing membrane is laid. You can directly place the reinforcement steel over it and then pour the structural concrete. So these are some of the side photographs application how this waterproofing membrane is done. So here you can see that this is waterproofing membrane proof engage is laid on the PCC or on the vertical side on a sacrificial formwork, and you can place the reinforcement directly on this product because this is a very robust product with a very high puncture resistance. There is no protection required over this. You can place the reinforcement directly and then pour the concrete over it. So on the vertical surface, when this membrane is fixed, it is fixed on either cement board or a sacrificial formwork, or you can even use a marine grade plywood. It is fixed using a double-sided tape on the vertical surface, just to secure the membrane in position till the concreting is done. Some more photographs like on the vertical side, and you can see the spacer bar here. This product can also be used for the double-sided formwork application, where you can fix the waterproofing membrane inside the formwork, and then the formwork is erected and the concreting can be poured. So here you can see the application photo. So this is the vertical surface on which the membrane has been applied, and the horizontal surface, all the pile head detailing will be done, and the reinforcement can be directly placed over the membrane. So here is another side photo where an application is done on a confined retaining wall. Here you can see this is the shoring face of the foundation, and then the waterproofing membrane is fixed on the surface with the one side formwork. The retaining wall casting is carried out. So this is one of the typical application of a proof engage for a confined retaining wall. So here you can see for a double-sided formwork how this product has been used. So this is a building where you can see here you can see the waterproofing membrane outside. So this membrane was fixed inside the formwork and the concrete was poured. After the formwork was removed, the waterproofing membrane you can see on the vertical surface, and the black dots and the vertical lines what you're seeing here, basically the vertical lines are the overlap joints of the membrane which needs to be filled later, and the black dots are basically the tie rod holes through which both the formworks are connected. So this also needs to be sealed once the formwork is removed. This product has been very extensively used for many underground structures. This is one of the tunnel waterproofing projects. This was the Riyadh Metro in Saudi Arabia, where for a station box, this product was used for the vertical sections as well as for the horizontal locations of the station box. So some more application photos you can see here. Also, it is suitable for other types of structures like cut and cover tunnels or any kind of box structures where a pre-applied waterproofing system is required. So this is how the cut and cover application is done. Here you can see this is the retaining wall, and this product is applied on the external side, and then later the backfilling is done. Some more photos of the site application of this waterproofing membrane. So now I'll just give a glimpse of a case study of a project where this product was very extensively used. This is a project in Qatar which is called the Mega Reservoirs project, which is one of the largest water storage reservoirs in the world. Which every reservoir, there are about 15 huge reservoirs, and every reservoir the storage capacity is about 100 million gallons of water. And this project, it is in the Guinness Guinness Book of World Records, the largest drinking water reservoirs in the world. This work was executed in the year about 2015 to 2018 for 3 years. And here, if you look at the design of that waterproofing system for this water storage reservoir, because this reservoir, the height of this reservoir is about 12 meters, 6 meters buried inside the earth, and 6 meters above the ground. And the waterproofing system was done for the portion of the reservoir which is 6 meters into the soil. So here, if you look at the detailing of the waterproofing system here, the waterproofing system was applied on the pieces of the blinding concrete, and then there were multiple layers of water stops that were provided, because since it is a water storage reservoir which stores a lot of water with a huge quantity of water. So there are some trenches for monitoring any kind of water leakages. So these are the U trenches which are provided below all the construction joints and all the expansion joints. In case of any water leakage through this structure, the water will be collected in this trench, and it will be with the interconnected pipe, it will be taken to a sump area. So this was the basic design of the reservoir slab. In this case, you can see this waterproofing system was applied over the PCC, and then there was an external water stop which was provided on the expansion joint as well as in the construction joint, and there was also internal water stop which was provided in the expansion joint and construction joint, and then there is another layer of water stop on the top side which is called the top cap PVC water stop, which was provided only on the expansion joint. The basic reason for doing all this is since this is a very huge reservoir, every reservoir stores about 100 million gallons of water. So the water pressure was very, very high. And also since the reservoirs are buried inside the earth, 6 meters of the reservoir is, below ground. So the contaminations in the groundwater also should not happen, should not get mixed with the water inside the reservoir. So the multiple layers of protection was provided in the base slab as well as on the retaining wall. So here you can see these are basically the column thickening areas where there is a trapezoidal section on which this membrane was applied, and this is the typical design of an expansion joint where multiple layers of PVC water stop along with the Proofex engaged membrane was applied. There is a waterproof sealing tape which is applied on the top of the joint. So these are some of the typical application site photographs of the product. Here you can see the Proofex engaged membrane has been applied on the PCC. Then there is a external water stop which runs on all the construction joints which will come on the wrap slab. So some more photographs. You can see the kind of the reinforcement here, which are basically epoxy coated rebars and very heavy density reinforcement, because like I mentioned, this product does not need any kind of a protection. So this is a very robust waterproofing system so that they can directly place the reinforcement, and then it will withstand all kind of site abuses during the site activities. So some more photographs of the project. So this was a very huge project, and one of the largest waterproofing job, I would say, where 400,000 square meters of waterproofing membranes were installed, and then more than about 5,000 square meters of self-adhesive waterproofing membrane was applied to the vertical side, and you can see the quantity of water stops used in this project was 90 kilometers of PVC water stop, internal and external PVC water stop was used, and then roughly about 110 kilometers of reinjection hoses, and then 120 kilometers of sellable water. But it's a huge project, one of its kind in the world, where this particular product Prufix Engage was used for the waterproofing of the structure. So the total order value was roughly about 11.5 million worth of material was sold in this project. So we have another type of pre-applied waterproofing membrane, which is not based on the chemistry of a chemical adhesion. Like the previous one, what I discussed about is a product which has got a mechanical adhesion which bonds to the freshly poured concrete by mechanical adhesion method, and we have the other product which bonds to the fresh concrete is a chemical adhesion system mechanism. So here we are one of the leaders in this type of a particular product. Since this product was launched, more than 50 million square meters of this product has been used in many projects all across the world. So the application of this product is also similar to the previous one. Here you can see that on the PCC there is a waterproofing membrane which will be applied, and then all the construction joints will be treated with a swellable water bath, and then the concrete is casted. So it can be done on the horizontal side and also for the vertical side for the confined area. So this is some application photograph of the site. In this membrane, you can see that all the membrane joints will be heat welded, so that the joints will remain secured, during its service life. The joints will not open up, and it remains completely watertight. These are some of the application photos where you can see the waterproofing membrane has been applied, and then the reinforcement bars are directly placed over the waterproofing membrane. And then wherever you have some, like any wall or any kind of a lift pit or any other projections on the raft, there there is a PVC water stop which will be provided, because sometimes what happens is after the casting the raft, you'll be having a construction joint. So at that construction joint predetermined location, you can fix a PVC water stop before the concreting works. So here you can see a lot of penetrations and pipe, pressure release pipes and other things. A lot of pipe provided here. This is drainage pipe and also the PRP pipes and all that. All these are embedded into the waterproofing system, and we do the proper sealing using an epoxy grout around all these pipes. And then finally the concreting is done up to half the thickness of the water stop. So the concrete is directly poured to this membrane. So once you pour the concrete, because there is an adhesive on the top side of the membrane, it bonds to the freshly poured concrete. So there are different products available depending on the different site conditions. We have to select the type of product that needs to be used. And all these products are available at different thicknesses. We have 1.2, 1.5, 1.8 millimeters. So depending on the thickness of the raft and the size of the rebar that is used for the construction of the raft, so you need to select the right waterproofing thickness. So important parameters of the product is like I mentioned, that this product is very robust and doesn't get easily damaged during the normal site activities of pouring the concrete. So it has got a very good puncture resistance, which has been tested as per SME 154. And then this product, once we lay it on the blinding, it has got a very good UV exposure. Like normally what happens is we do the we apply the waterproofing membrane on the PCC or the blinding, and then the concrete is activity is done after say in some cases 1 month or 3 weeks or 4 weeks. So till the time the waterproofing membrane should not lose its property, and then it should be able to bond very well with the concrete, fresh concrete. So there is a UV exposure test which is done as per SMG 154, and then the joint strength is basically the strength of the overlaps of the membrane, which is tested as per ASTM B692. And then the peel adhesion. Peel adhesion is basically how good the bonding of this concrete, of this membrane is with the concrete. So all these tests, or 4 important tests, are carried out for any kind of a pre-applied waterproofing membrane to ensure that the quality of the product is as per the specification or as per the requirement. The same product can be used for the horizontal as well as for the vertical application. You can see here, this is applied on the vertical side using a double-sided tape to keep the membrane in position till the time the concreting is done. So here you can see a show pile where all the gaps between the piles are filled with a lean concrete, and then this membrane is fixed on the vertical side. In certain cases, when we do the waterproofing, where there is a high water table area or multi-level basements are there, so where to ensure a proper water tightness, the double layer system is done. So we have some special products which are used for the double layer waterproofing system. So in this case, the first layer is done, and then the second layer of waterproofing is done over the first layer with a staggered joint. So these are some of the application photos of the double layer waterproofing. You can see here, this is a surface which is made, smooth or flat after application of lean concrete, and the waterproofing membrane is the first layer of waterproofing membrane is installed on that surface. Here you can see this is joint of the first waterproofing membrane, and the second waterproofing membrane will be applied over the joint of the first, so that this joint is concealed and the water tightness can be better in this case. So when it comes to the pre-applied waterproofing membrane, we have two brands available in Saint-Gobain. One is the Fosroc membrane HDPE, and then the other one is pre-proof. Both the brands are available for Sri Lankan market, and the Fosroc membrane HDPs are basically the sand finished membrane, which has got a sand finish on the top, and the pre-proof brand is a smooth finish membrane, which is a product well known in the global market and which has been used in many prestigious projects across the world. And this is one of the case study of a project for a metro station in Denmark, where you can see on the shore piling, this product was applied before the concreting works, and you can see here a lot of penetration that passes through the waterproofing membrane, which are sealed as per using different sealing materials. Another case study of this product used in high-speed rail project in the UK. So here also it was used for basically for the base slab, and here we use a combination of different kinds of waterproofing system. Basically for all the cut and cover tunnels, for the NATAM tunnels, it was you can see here there is a Proofex Alcor plant, which is a flexible PVC sheet which are used for the NATAM tunnels, and for the cut and cover tunnels, the Proofex Engage waterproofing system was used. So it's a combination of various projects, because the main requirement in this project was to have a product with a design life of 120 years. And since all these products are tested for design life of 120, so these products are approved and was used very extensively in this project. For buildings, if you see, for data centers, this is one Singapore case study in Singapore, where Proofex Engage, the pre-applied waterproofing membrane, was used for below the on the raft slab, about 34,000 square meters of area. This is a 5-story data center in Singapore, where various products of Fosroc was used for various waterproofing applications. So, like, there are other applications for the for the waterproofing membrane. For example, When it comes to the unconfined retaining wall, unconfined means if there is a working space between the excavated surface of the soil and the retaining wall, it is called an unconfined retaining wall, where the waterproofing is done after the retaining wall is constructed. So in that condition, you have various options of material available for waterproofing. There is a liquid applied system based on hybrid polyureas. There are self-adhesive waterproofing systems based on HDPEs, and there are self-adhesive bitumen membranes. So polyurea waterproofing is a liquid applied system where you can see it's a spray applied waterproofing system. There are different grades of polyurea available. There's an aromatic polyurea and aliphatic polyurea. Aromatic polyureas are basically the products which are not UV resistant and have to be used in concealed application which are not directly exposed to sunlight. And the grade of polyurea which is used for the waterproofing purpose is basically a hybrid polyurea. So what are the advantages of this product is basically it is a system which is very robust and I would say that it's a product with very high mechanical properties and it is a spray applied system which after application it cures within 10 seconds and any kind of water ponding test or it can be left exposed to rain or any other site activities after 3 hours of application. So it is a product where you need a continuous waterproofing system, a seamless, a jointless waterproofing system, whether it is a roof slab or in case of any retaining wall or any kind of an internal surfaces where you need a jointless waterproofing system, polyurea is one of the best options. So here also we have done the service life testing for this product as per ES 13251. And this product is highly elastomeric in nature. It has got a good crack bridging property also. It has been tested for static crack bridging of 8 millimeters and dynamic crack bridging of 3.2 millimeters. It means that when a waterproofing treatment is applied on this concrete substrate, in the event of any kind of a cracking in the substrate, these products are able to withstand, the crack movement without compromising on the waterproofing integrity of the structure. So the method of application is basically it's a spray applied system. You can so you can see here so once the waterproofing system is done on any external wall, the retaining wall, then we put a protection board of a drain or a dimple sheet before the soil backfill is done. So the advantage of this product, like I mentioned, that there is no joint in this waterproofing system. It's a continuous waterproofing, and it has got excellent resistance against root penetration or any kind of attack by the subsoil chemical. So normally the waterproofing, this section you can see here, you have the PCC or the blinding concrete on which the waterproofing, which is a pre-applied waterproofing membrane is applied, it's a sheet waterproofing membrane. And then the spray applied waterproofing membrane is done on the retaining wall, which will be overlapped here with over the waterproofing membrane, which is coming from the raft slab. And all the construction joints will be treated with a hydrophilic water bath. Some more applications, like wherever you have a post-construction waterproofing requirement, there is a post-applied waterproofing system, which is called a self-adhesive HDP-based waterproofing system, which can be done for retaining walls as well as for the individual footings, any kind of lift pits, all these applications. This is a very easy application, like a peel and stick method. After proper surface preparation of the substrate, you can directly apply this sheet on the substrate and then you fix a protection board and then backfill this area with soil. So here we have an adhesive which is used, for example, if you have a substrate which is wet or damp. So there is a special adhesive which, for example, if you want to do a waterproofing application immediately after rain, so there is a special adhesive available with which you'll be able to apply the waterproofing material even if the concrete surface has got high residual moisture. So some more applications of this product. So coming to the another treatment what normally we do in substructure waterproofing is the pile top treatment, because certain type of foundation design you need the the pile foundation. So on that there is a PCC layer with the pile protruding from that area. So this is a very important point in any waterproofing system that needs to be properly sealed. So here the blue line, what you're seeing is the waterproofing membrane which will be taken up to the pile head level, and then the reprofiling of the pile is done with sorry with a cementitious micro concrete, and then there is another layer of an epoxy grout which will be applied over it. This is to prevent any kind of water ingress to the reinforcement part. So here you can see that how the pile head treatment is done. So this is waterproofing layer, and this is the pile head. The broken pile head is has to be reprofiled using a micro concrete. Once the reprofiling is done, this will be the finish. After the reprofiling, there is a second layer of waterproof epoxy grout which will be applied onto the top surface and onto the side. So some more application photos of pile head treatment. You can see this is a Pufix engage waterproofing membrane, and then the pile head treatment has been done with an epoxy grout here. Another important, treatment that is normally done in areas where very high water pressure is there is to do the rock anchoring. So rock anchoring is done if there is a very high water pressure which has got a capacity to uplift the raft foundation. In that case, there is a rock anchoring which is done where the raft will be anchored to the base using the rock anchors. So these rock anchors, most of it will be passing or puncturing through the waterproofing membrane. So it is very, very important that all these penetrations are sealed properly with an epoxy grout. Coming to the tie rod holes, when we have two sides, when a retaining wall constructed with a two-side form box, you will be having a lot of tie rod holes in the structure which are potential parts of the water leakage. So all this needs to be properly sealed using a proper water-tight material. So here you can see the application, how the application is done using a sealant gun. We load the the tie rod hole repair motor, and then it is injected into the tie rod hole. The sealing is done and the waterproofing is carried out. So when there is a construction joint or an expansion joint in a structure, there is a lot of there's a possibility that the water can get in through those joints. So there are sealing systems available for those joints, which are PVC water stops, which are placed on the external side on the construction joint or in the middle of the construction joint. There are different profiles available for the PVC water stops. Some profiles are used for the construction joints, which are placed internally or externally, and there are other profiles which, with a central bulb, is basically used for the expansion joint. So when there is a movement of the expansion joint, this central bulb is provided for to release the stress, which will also expand along with the movement of the structure, because all these water stops will have an elongation of almost 300%. So these are some of the applications of the PVC water stops. Wherever there is a construction joint or an expansion joint, these are provided to make the joint watertight. Another type of water stop that is used for the joint sealing purpose is a hydrophilic water bar. If we cannot provide a PVC water stop, the hydrophilic water bar is provided. These type of water bars, when it comes in contact with water, it swells and then it fills the joint. So these are typically the products which are used for sealing any kind of a construction joint in the concrete or any kind of an I-beam penetration or any kind of a pipe penetration to the concrete where you need to make that penetration point completely watertight. So coming to the end of this presentation, I'll just give a the recap of it. So the selection of the appropriate waterproofing system is very, very critical because, like I mentioned, that substructure waterproofing, the right system has to be selected at the time of construction. Otherwise, it's very, very difficult to do any kind of a in repair, or it is not possible to redo the waterproofing in case of a substructure. So there are different choices of materials that are available. Like we discussed about the preform sheet membranes, which are based on HDPs and bitumen sheets. And then there are cold applied or hot applied liquid type of waterproofing systems, which are based on polyurea. For the post applied waterproofing systems are available. As per the BS 8102, it is very, very important that we use the pre-applied waterproofing membrane. Like I mentioned, that a pre-applied waterproofing membrane is a system which bonds to the fresh concrete, and even in case of any settlement of the structure, since the waterproofing integrity of the structure can be maintained. And then the most important thing is that special attention must be given to all the detailing in the waterproofing. For example, any kind of a construction joint or an expansion joint or a pilot penetration or any kind of a service penetration, which can form a discontinuity in the waterproofing membrane. So enough attention and care must be given for sealing all those locations in the waterproofing system to ensure a complete water tightness. And finally, the waterproofing system must always be installed by a specialized and trained applicators. So for Stock, Criso, we have got our own authorized applicators. We provide very extensive training to our applicators. So we also provide application support. So any waterproofing application for a critical structure, it is always good to carry out the work, through an authorized or a trained applicator. So that's it. Thank you. So any questions?
The Q&A session. We have few questions already in the group, in the live chat. And if you have more questions, you can put your questions in the YouTube live chat. We will direct your questions to the resource person. I think this question, first question is for Dr. Tushara. To achieve 85 MPa, we have to use 600 kg or binders. You mean Sri Lanka? That's the question. You can maybe.
What was the question?
To achieve 85 MPa, we have to use 600 kilogram or binders, cement fly ash and silica film in Sri Lanka.
No, actually, as I mentioned previously, so I think it should be always try to be below 550. So you can make it with different material based on your equipment.
Thank you, Dr. Tushara. question is for Mr. Parameswaran. Yes, Mr. Parameswaran, this question is for you. For the waterproofing of the gutters when using a spray type material, how many years need a warranty for this? If I break down the question again, how many years warranty we need for a waterproofing material that is spray type used for the gutters?
Okay, when you go for a spray type waterproofing, which I mentioned, polyurea waterproofing. These type of products normally, like depending on the quantum of the work, the manufacturer warranty will be roughly about 10 years for this kind of product. So even though it has been tested to have a service life of more than 25 years, on the manufacturer side, the warranty will be for 10 years, provided it is applied as per the manufacturer recommendations and methodology.
Thank you, Mr. Parameswaran. I think we do not have any more questions since we haven't received any in the chat. So with that, we will conclude the session. But before that, I would like to thank Professor Priyan Mendes first for joining despite his busy schedule to introduce our speakers and introduce the session today. And Dr. Tushar Priyadarshan and Mr. Parameswaran for delivering such innovative and insightful sessions on this topic, built for 100 years, high performance concrete chemicals and materials. And I believe your presentation on this latest advancement in high performance concrete and innovative construction materials have undoubtedly provided immense value to all our participants. It was truly an engaging and thought-provoking session. So we sincerely appreciate your time and expertise, and we are grateful for this opportunity to collaborate with the Open University and resource incubation and postdoc companies in our shared vision of building a knowledge-based society through SDI. And let me remind you again about the Google form. This Google form will only be open for another 10 more minutes. So if you are interested in receiving the certificate for this session, please go ahead and mark your attendance as soon as possible. We have given the Google form link in the YouTube live description and as well as the YouTube live chat. So make sure you correctly input your details so that you will get the certificates with correctly. And if you experience any issues accessing the form, please take a screenshot of both the error and the YouTube webinar page and send them to us via WhatsApp or email. We will be assisting you with that. And yes, also thank you, Dr. Tushar and Mr. Parameswaran, for taking your time to answer the participants' questions and sharing your valuable expertise. Before we wind up, we have a few announcements to be made on behalf of SDI. So we have the AutoCAD course and the SAP 2000 courses scheduled to start in this month. So on the 22nd of July, we have the Autodesk course starting, and the SAP 2000 course will be starting on the 31st of July. So if you are interested in joining any of these courses, you can register through the links that we have provided in on our social media platforms, or you can directly contact us through WhatsApp or email. We will provide you with the details to register for these courses. And also we have an upcoming event which will be happening on the 24th of July, next Friday at PMICH. And we have Professor Mark Stewart, Professor Brian Liu, and Professor Ramsey Pisanayaka as chief guests and guest honors. And keynote speakers, Professor Priyan Mendes, Associate Professor Damit Mohuti, for this upcoming event, which is designed to survive tall buildings in an age of global instability. which is a forum that we are conducting for the Council on Vertical Urbanism, Sri Lanka CBU, as the Colombo Forum. So you can scan the QR code on the screen and register for this if you're interested in joining. And with that, I think we can conclude today's session. And to all the participants, thank you for joining today's webinar. And we hope you found this webinar informative and engaging and beneficial for your development. We would like to extend our sincere appreciation to the Open University and Christos and Cobain and Postdoc for partnering up with the SDI in organizing this knowledge sharing session. And finally, if you're interested in joining any of our courses and any of our events, you can contact us through the links that we have provided in the screen. So with that, thank you everyone for joining and hope to see you all at the next webinar.
Thank you.